Friends, in this video we'll understand how to calculate the balancing factor in a AVL tree, which is used for deciding how to rebalance the tree. Unbalanced tree is a tree in which the height of a particular path is longer than the remaining tree. So we want to normalize the path so that at most one or two nodes have a extra one or two paths have an extra node. Otherwise all the paths are ending at the same level. That is a balanced binary tree. So as you can see at the bottom of the page, we have shown the calculations of the balancing factor. First of all, we need to calculate the heights of the tree, which I have shown in the previous video, and here we will be calculating the balancing factor. For quick understanding, let us see that the node 10 has a height of 0, then 40 has a height of 0, 80 has a height of 0, 20 has a height of 1, uh, then 30 has a height of 2, 70 has a height of 1, and 50 has a height of 3. So as we can see here at the bottom, we have written all the nodes once again, and then we will look at what is the height of the left subtree and what is the height of the right subtree, and we will subtract the values and we will get the balancing factor of that particular node. So for node 10, there are no children. So therefore, the heights of null children is -1. So both the left and the right subtree, they have a value of -1, -1. So -1 plus -1 will give us a value of a -1 will give us a value of 0. Then for node 20, we have the left subtree is node 10, which has a height of 0, and the right subtree is missing, so it has a value of -1, and therefore we have 0 minus -1, and so we get a value of +1. Similarly, for node 40, there are no children, so therefore the balancing factor is a 0. Then for node 80, there are no children, again the balancing factor will be 0. Then for node 30, there are two children, 20 and 40. So 20 is the left subtree and 40 is the right subtree. Height of 20 is, as we can see from above, height of 20 is 1, height of 40 is 0. So 1 minus 0 will give us a value of 1. Similarly, for node 70, we have the left subtree is null, so it is height of -1. 80 has a height of 0, and therefore the balancing factor is -1, because -1 minus 0 will give us -1. Then we have the node 30. Node 30 has, 30 we have already calculated. Then we have node 50. So for 50, there are two children, 30 and 70. 30 is the left subtree with a height of 2, and 70 is the right subtree with a height of 1. So 2 minus 1 gives us a value of 1. So as we can see at the starting of the page, we have written height of the left subtree minus height of the right subtree should be less than equal to 1. It has a range of values from -1, 0 and 1. The balancing factor's value should be either 0, -1 or 1, and if the value falls within this range or sequence of numbers, then we can say that the tree is balanced. Otherwise the tree is unbalanced and we need to balance it. We have seen how to calculate the balancing factor. In the next video, I'll be discussing how to balance the tree.